Have you ever wondered how credit cards work? Well, in the olden days, people had to rub carbon paper onto embossed numbers to enter their credit card information. Well, nowadays, with just the swipe of a card, you'll be able to do the same. Well, how does this work? In this video, I'll explain how electromagnetism can be applied to credit cards. This is a credit card. It was invented with the aim of facilitating the payment process of goods and services. Thanks to the credit card, people no longer have to carry around large amounts of cash. And credit cards also offer a variety of rewards, and this makes them advantageous compared to other payment methods. So, cashbacks, travel miles, and discounts are just a few examples of these perks. So, what differentiates the credit card to the debit card is that in a credit card, individuals can borrow money from a financial institution, and almost always this financial institution will be a bank. So, a limit is set to the amount of money that can be borrowed from the bank, and within a predetermined time period, this money has to be paid back. Well, if it is not, and here's the catch, the money needs to be paid back later, but with interest. So, the longer that somebody takes to pay back a bank after their paying period is over, the more additional money that person will need to pay. So, if you want to use a credit card, simply carry it around with you for whenever you need to make a purchase. And nowadays, most stores, and especially the more developed ones, do accept credit cards. And you can only use a credit card if the store has a credit machine or credit card reader. And when making the purchase, simply swipe the card across the slit on the machine, like so. And what happens when somebody swipes their card across a card reader is that the information on the card is sent to the machine. And the machine processes this and matches it to the database that is created from the financial institution. So the cardholder's name and very essential information will be stored on the card. And if it matches the database, then that's a good thing because the card is not counterfeit. And if it matches, the card will or the machine will check if the person has enough money or enough credit to make the purchase. If the person does, then the payment goes through after they enter the PIN number. So, this entire process is very interesting. But what exactly happens on a microscopic level during that swipe of the card from the credit card onto the machine? Well, this black strip on the back of a credit card is not there for nothing. It's called a mag stripe, and it stores essential amounts of information for purchasing items, such as the cardholder's name, account number, and card expiration date. So, to make the mag stripe, a compound like iron oxide or barium ferrite will be ground up into fine powder and combined with a plastic-like material. So, this mixture is then stamped onto the back of the card, and the strip is formed by magnets arranged in a combination of unique patterns. And this pattern should not be visible to the naked eye. These unique patterns are what code for the information on the card. So now this is a card reader, and it is actually a deconstructed version of a card reader. It's more of an old-fashioned one, but the card magstripe is also more of an old-fashioned model of credit cards, so that makes sense. So in a credit card machine, there are coils of wire, like you can see in the red part, and when the credit card is swiped onto the credit card reader, the magnets in the magstripe causes a disruption in the magnetic field of the coils in the machine. Well, okay, how does this work? Since the wires are made up of metals, they have their own magnetic fields. And when another set of metals or another set of magnets are then in contact with them, this magnetic field disrupts the other magnetic field. And when this disruption occurs, a voltage is induced. So that's where the electro from the electromagnetic process comes from. So now this voltage is used to power the transmission from the card onto the machine. And now remember that what is causing this entire disruption is the magnet that codes for the information from the card. So basically this means that when the magnetic field is disrupted, the information on the card is also sent to the machine. So now the way that this happens is that the signal from the magnetic signal that is turned into analog signals, and the analog signal is the only thing basically that the card reader can interpret. Obviously, the card reader can't interpret like magnetic fields. So now that the machine has the information from the card, that's when the process that I talked about earlier with the information being matched with the database occurs. Well, does this mean that placing a magnet near a credit card can deteriorate it? Realistically, not really. The magnets that are currently used by most people, they don't they're not exactly strong enough to actually deteriorate a credit card. But if the magnet was really strong, it probably could. The technology of payment methods like credit cards is advancing rapidly. And although the physics behind the credit card and the credit card machine is fascinating, the payment method is not as safe as some other developments that have come in recent years. So nowadays, the mag stripe on the credit card is largely replaced by what is called an EMV chip. So EMV stands for Europay, MasterCard, and Visa. And so this system, the EMV, is much more secure than credit cards because the credit card or the credit cards using MagStripe only hold static information. And what this means is that the information on MagStripe credit cards does not change. So the account number, the cardholder's name, and the expiration date, those are things that do not change or should not change. But in an EMV card, when the payment is conducted or every time someone pays for something, the card creates a code for it. And that code is what matches with the database found in the separate system. So it's more of a complicated system, but it's much more secure because when the information on a credit card is always the same, it's much easier to simply copy it and then use it. Whereas in an EMV card, maybe you can copy the information, but the next time you try to use that information, the code will already be a different one. And these are my citations. So thank you for listening to my presentation about credit cards, and I hope you learned something new about electromagnetism and credit cards.